Okay, so you've been looking into space colonization. And I gotta say, some of the stuff that's being talked about right now is, well, it's pretty mind-blowing. I mean, we've pulled together a whole bunch of different perspectives for you. From the straight science documentaries to these like really enthusiastic visions of like what's out there. But also I'm seeing some really big questions being raised about, how we'd even do this whole space colonization thing and why we should even bother.
Yeah, and I think what jumps out, what really struck me going through all this material is this kind of like push and pull, right? I mean, on the one hand, you have this like fundamental human drive to explore, but then you've also got this really, really compelling argument for, needing to find ways to keep humanity safe in the long run, like maybe establishing ourselves on other planets is the way to do that. But, and this is a big but, going to places like Mars, the moon, or even trying to use stuff from the asteroid belt, there are some massive, massive challenges there. Practically speaking, ethically speaking, it's a huge undertaking.
For sure. So what we're going to do today is like really get into it, really unpack all this stuff. We're going to pull out the main ideas that are floating around out there about where we are with space colonization, what are the real obstacles and roadblocks. And there's a lot of cool debate happening around this. I mean, really fascinating stuff. And we want to like break that down in a way that makes sense. We're not trying to give you a lecture here.
Right, exactly.
Okay, so let's start with like the most basic question. Why are we even talking about this? Why are people saying we need to colonize space?
Well, one of the biggest arguments that I saw popping up over and over again is the survival thing. Like, we need to do this to survive. A lot of the stuff we looked at was talking about how Earth might not be such a great place for us in the future. Could be climate change, could be too many people, overpopulation, or even, yeah, it's a long shot, but a big asteroid could hit us. So space colonization, some people are saying it's like an insurance policy. It's a way to guarantee that humans and maybe even, all the other living things on Earth can survive. If we're not all crammed onto this one planet, we've got better odds.
So it's not just about like boldly going where no one has gone before, right? I mean, it's really about not putting all our eggs in one basket, a
Mhm.
basket that's looking a little wobbly.
Yeah, exactly. And it's not just about avoiding disaster. There's the resources too, right? I mean, space, especially the asteroid belt, it's just full of, it's almost impossible to grasp how much stuff is out there.
No, I know. I was reading that. Like, if you just take the asteroid belt, the resources there could support way, way more people than Earth can. Like, many times over, it kind of changes how you think about resources. You know what I mean?
Absolutely. And the stuff they're talking about, basically unlimited materials, energy, it really gets you thinking. Like, what if this leads to like a whole off-world economy?
Hmm.
An economy in space that in the next century, some people think it could be bigger than Earth's economy. Think about it. We could be mining asteroids not just for, metal and stuff, but for water. Water we could turn into rocket fuel.
Hmm.
And then there's stuff like manufacturing in space, maybe taking advantage of zero gravity or something. And hey, even space tourism is on the table, right? It could be a huge industry. But here's what really gets me. It's not all about just like surviving or making a buck. There's this other piece too.
Totally. I see that coming up a lot. It's this human need to explore, to push boundaries. It's almost like it's built into us. We got to see what's over the next hill. It's that same drive that led us to like discover all the continents and everything. I mean, it's a powerful thing.
Totally, yeah. A lot of these pieces were talking about this instinct, this drive to find new frontiers. It's that drive that's led to every major discovery and, us spreading out across the planet. And now it's like that drive is pushing us even further out into space.
And then there's the science part of it. I mean, can you imagine what we could learn if we had like research outposts on other planets or moons?
Oh, for sure. Imagine like being able to study the rocks on Mars firsthand, or figuring out what asteroids are made of, or maybe, just maybe, finding evidence of life, past or present, somewhere else in the solar system. I mean, that would completely revolutionize our understanding of, well, everything. The solar system, how life began, the laws of physics, everything.
Okay, so we've got some good reasons to do this, but where are we actually going? The moon, Mars, asteroids, those keep popping up. Let's start with the moon. It's our closest neighbor, so what makes it like a good place to start?
Well, the big thing with the moon is it's close. The travel time is super short, just a few days,
Right.
and communication is easy. One of the things we read said there's like less than 3-second delay in communication. So you could basically have a conversation in real time.
Yeah.
And, there's that water ice at the poles. We know it's there for sure now. And that's been a total game changer. It's made people way more interested in the moon.
Yeah, that lunar water ice is like the big deal? Why is that so important?
Well, think about it.
Huh.
We need water to live, right? But water is also made of hydrogen and oxygen. And guess what? Those are the same things you need to make rocket fuel. So the moon could become this, like, gas station in space, like a pit stop. You fill up your tanks on the moon and then head out deeper into space, maybe even to Mars. Plus, it's way easier to launch stuff off the moon. The gravity's way lower, so you don't need as much fuel.
Makes sense. But it can't be all sunshine and roses, right? I mean, what are the downsides to living on the moon?
Oh yeah, there are definitely some serious challenges. The biggest one is probably the gravity. It's so much lower on the moon that it could really mess with your health in the long term. And there's no air to breathe, obviously,
Mm.
and radiation is a huge problem. You're basically exposed to all the radiation from space. And then there's the temperature. I mean, it swings hundreds of degrees between day and night. That's got to be tough to deal with. And then there's the dust, lunar dust. It gets everywhere. It's super fine, and it can really mess up your equipment. And some sources even mention, like, moonquakes, seismic activity. So yeah, not the easiest place to live.
So how are we supposed to live there? How do you even build a place to live on the moon with all that going on?
Well, there are a bunch of really cool ideas out there. The European Space Agency has this moon village concept. It's basically like an international effort to build a permanent base on the moon. And a lot of people are talking about mining on the moon. There's this stuff called helium-3 that some people think could be used for clean energy in the future. And of course, space tourism is a big one. People are already planning to send tourists to the moon.
Wow, so where are they thinking about building these moon bases?
They're looking at a few different spots. The polar regions are good because there's water ice there.
Hmm.
And you can find spots where the sun shines almost all the time. So you've got water and energy right there. The equatorial regions might be good for helium-3 mining. And some people are talking about the far side of the moon. It's really quiet there in terms of radio waves, so it would be a great place for radio telescopes. And some people have even suggested using these things called lunar lava tubes. They're basically caves that formed from ancient lava flows. They can be good for shielding from radiation and temperature swings, and they're thermally stable.
So we could be living in caves on the moon. That's wild. But how do you actually build stuff on the moon? I mean, there's no atmosphere and the conditions are really harsh.
Yeah, it's tricky. One idea is to modify existing lunar landers or use the empty parts of them as shelters. Another idea is to use inflatable habitats, basically giant inflatable tents. Or they could build prefab structures on Earth and then just ship them to the moon and assemble them there.
Yeah.
But the really cool stuff is in 3D printing. They're working on ways to use linear regolith, the stuff on the surface of the moon, to 3D print buildings and other structures. There are these concepts called contour crafting, and some architectural firms like Foster Plus Partners are designing these amazing lunar habitats that could be printed right on the moon. And there's this thing called microwave sintering, where they use microwaves to melt the lunar regolith into bricks.
So basically using the stuff on the moon to build stuff on the moon. That's pretty smart. Now, what about this lunar gateway thing? NASA keeps talking about that. What's that all about?
So the Lunar Gateway is supposed to be this space station in orbit around the moon. It would be used for research and as a kind of staging point for missions to the surface. But there's been some debate about whether it's really necessary. Some people think it would be cheaper and faster to just land on the moon directly. And there are questions about whether it can handle really big spacecraft like SpaceX's Starship, which they plan to use for lunar landings.
So there are a few different ideas out there about how best to get back to the moon and set up shop there.
Okay, let's move on to Mars, the red planet. A lot of people are excited about Mars. Why is that?
Mars is kind of special because out of all the planets in our solar system, it's the most similar to Earth. It's got a thin atmosphere, mostly carbon dioxide, but it's there. It's got polar ice caps. And we know there used to be liquid water on Mars, and there might even be some underground now. And Mars has seasons, kind of like Earth, and even a day-night cycle that's almost the same as ours. So in some ways, it's more like Earth than the moon is.
Right, but it's also way farther away, right? That's
Yeah.
got to be a problem. Oh yeah, definitely. It takes 6 to 9 months to get to Mars, one way. So it's a long time to be in space, exposed to zero gravity and radiation. And Mars does have an atmosphere, but it's way too thin to protect you from radiation or to fly a plane in.
Huh.
So landing on Mars is hard. And the surface is covered in this fine dust that could be toxic. So yeah, living on Mars would be tough.
Sounds like a pretty challenging place. So what are people doing to try and make it happen?
NASA has their Journey to Mars program, which is all about sending humans to Mars, maybe sometime in the 2030s. They're going to start with missions to orbit Mars, do some science, and scout things out. But SpaceX, they're even more ambitious. They want to build a whole city on Mars, a self-sustaining colony. Their plan is to use this giant spaceship called Starship, which is designed to be fully reusable. And they want to refuel Starship in space so they can carry more cargo to Mars. And their big idea is to figure out how to make rocket fuel on Mars using stuff they find there. Elon Musk, the guy who runs SpaceX, he keeps saying that we have to get the cost of going to Mars way down if we want to make it happen. And landing Starship on Mars, that's going to be a huge challenge. They're working on that right now.
Wow, a city on Mars. That's crazy. So where on Mars would they build something like that?
Well, they're looking at a few different places. The polar regions have a lot of water ice, but the winters are long and dark there. The equatorial regions are better for sunlight, and some places there might have water ice underground. And some people have even suggested using the Martian moons, Phobos and Deimos, as like stepping stones. They're really small, so it would be easier to land and take off from them than from Mars itself.
So you could use the moons as like a base camp for exploring Mars. That's pretty clever. What kind of buildings would they build on Mars?
There's this one idea called the Mars Ice Dome, which is basically a big inflatable dome covered in a thick layer of water ice for radiation shielding. Another idea is to just bury your habitats underground, which would protect you from radiation and keep the temperature more stable. And of course, people love to talk about terraforming, which is basically transforming Mars into a more Earth-like planet. But that's like a super long-term project, and there are a lot of questions about whether we should even try to do that.
We'll get back to terraforming later. But first, let's talk about asteroids. They seem to be like a whole different ballgame.
Yeah, asteroids are all about resources. They're basically giant rocks in space, but they're full of stuff we need. There's so much material out there that it could fuel like a whole space industry. And a lot of asteroids have water ice, which is super valuable, as we've discussed. And because they have such low gravity, it would be easier to build big structures in space using asteroid materials.
So are we talking about living on asteroids or just using them as like a source of supplies?
At first, it's probably just going to be about mining. We could mine asteroids for water to make rocket fuel and for rare metals like platinum, which are really valuable here on Earth. There are already companies working on this like Planetary Resources, Transastra, and Deep Space Industries. The idea is that we could use these space-based resources to make space travel cheaper and easier, and maybe even start building big structures in space. Some people think that asteroids could be the key to like a whole industrial revolution in space.
But living on an asteroid, that sounds kind of precarious.
Yeah, it would be tough. Asteroids are basically just giant rocks with no air and almost no gravity. They don't offer any protection from radiation or, anything else that might hit them. But there are some ideas out there, like maybe you could hollow out a small asteroid and live inside it. Or maybe you could use a big asteroid as like an anchor for a space station or something.
Okay, so we've talked about why we might want to colonize space, where we might go, and some of the resources we might use. But how do we actually do it? What kind of technology do we need?
Technology is the key here. Every single source we looked at emphasized that. There are a lot of areas where we need to make big breakthroughs. For example, propulsion. We need better ways to get around in space. Companies like SpaceX and Blue Origin are already building reusable rockets, which is a huge step. But we need even better engines, more efficient fuel, stuff like that. And we need to figure out life support. How do you keep people alive in space for months or even years? We need systems that can recycle air and water and waste. And people are working on bioregenerative systems, where you use plants to produce food and oxygen.
So like a little ecosystem in space. Very cool. What else do we need?
Radiation shielding is a big one. We got to find ways to protect astronauts from radiation, which is a huge health risk. Water ice is actually a good radiation shield, and scientists are working on other materials too, and even things like plasma shields, which sounds like something out of Star Trek. And transportation is another big one. We need better ways to get to and from space, maybe hypersonic space planes or even space elevators, which would be amazing. And in space refueling, that's going to be important so we don't have to carry all our fuel with us from Earth. And we've talked about using resources on the moon and asteroids for fuel and building materials. That's going to be key. And building habitats, 3D printing is going to be huge for that. We need reliable energy sources for space, maybe better solar panels or small nuclear reactors, or even using geothermal energy on Mars if that's possible. And communication. We need better ways to communicate with people on Mars or farther out. We need relay satellites to reduce the time delay. And then there's the human factor. How do you keep people healthy, physically and mentally, when they're living in space for long periods? Scientists are even looking into artificial gravity.
Wow, so much to think about. It's clear that this is going to take a huge effort, a lot of people working together. And I've noticed that a lot of these sources are talking about how important it is to have both government space agencies and private companies involved.
Yeah, public-private partnerships are really important.
Mm.
Private companies are often really good at innovating and moving quickly, but they need the resources and long-term vision that government agencies can provide. So it's really about everyone working together.
Okay, so we've talked about why we want to do this, where we might go, what resources we might use, and the technology we need. It's clear that becoming a multiplanetary species is like a really big deal, but the payoff could be huge, right?
Oh, absolutely. It's a grand vision for sure. But it's amazing to see how much progress is being made. Scientists are learning more and more about space, technology is advancing really quickly, and there's a lot of public interest in this. So I think the next few decades could be really exciting. The first steps are probably going to be on the moon, using the moon as a base, to learn more about how to live and work in space. Then we can start thinking about sending people to Mars and eventually even to the asteroid belt. It's going to be a tough journey, but the potential rewards are huge. I mean, we could be talking about the long-term survival of our species and expanding our horizons beyond anything we can imagine.
It's amazing to think that all this stuff we've been talking about, this exciting future, it might not be that far off. Some of the stuff we read, they're talking about lunar bases within the next few years and people on Mars within the next decade. It's really not science fiction anymore. It feels like we're on the verge of something big.
It does, doesn't it? There's a lot of ambition out there, and things are moving fast. I mean, here we are talking about becoming a multiplanetary species. It makes you think about the meaning of life and
Mm.
our place in the universe. It's a really incredible time to be alive.
Okay, so we've covered a lot of ground today, and it's clear that space colonization is like a super complex topic with a lot of moving parts. But I think the really big question, the one we all have to grapple with, is this. If we do become a multiplanetary species, what kind of future do we want to create? Do we want to repeat the mistakes we've made here on Earth? Or can we learn from our past and build something better, something more sustainable, more equitable, something that benefits all of humanity? It's a challenge, but it's also an incredible opportunity.
I think that's the perfect way to put it. It's a challenge, but it's an opportunity.
Mm.
And it's something we all need to be thinking about.
And that's something for all of you listening to think about, too. As we venture out into the cosmos, what kind of future will we create? Thanks for joining us on this deep dive, and we'll see you next time.
See you next time.